In this video, we will cover using the first derivative to determine graph behaviors. By using the first derivative to cover graph behaviors, we can determine whether a critical point exists and whether or not that critical point is an extrema. Let's start by looking at the graph of f of x equals x. Looking at the graph of f of x equals x from the negative to the positive direction, would you say that it is increasing or decreasing?
I think that the graph is increasing because the y values increase as the x values increase.
Exactly. Now let's look at what this means for the first derivative of the function. The first derivative of f of x equals x is f prime of x equals 1. Let's look at the graph of this. We can see that no matter what the x value is, the first derivative is always equal to positive 1. We can generalize this finding to all functions. When the original function is increasing, the first derivative is positive. You may want to write this chart in your notes. Now let's look at an example of another function, f of x equals negative x. Looking at the graph of this function, do you think that it is increasing or decreasing?
I think the graph is decreasing because the y values decrease as the x values increase.
That's correct. Now let's see what the first derivative of the function looks like. The first derivative of f of x equals negative x is f prime of x equals negative 1. We can see by the graph that the first derivative is equal to negative 1 for all x values. We can generalize these findings to say that when the original function is decreasing, the derivative is negative. Again, you may wish to write this in your notes. Summarizing this information, we have determined the following chart.
I understand. When the original function is increasing, the value of the first derivative will always be positive. But when the original function is decreasing, the first derivative will always be negative.
Exactly.